Okay, this is integrated 2's video number 2 for special right triangles is 45, 45, 90. A lot of the same type of process, it's just that the pattern's a little bit different this time. So I'm going to say go through the exact same process that I did before. I'm going to start at the smallest angle. In this case, the smallest angles are both the 45s. So knowing that these two are the exact same size, I know that what is opposite them, again, smallest side is going to be A. But if they're both 45 degrees, then that means both of the sides opposite then are going to have to be congruent to each other. And then starting at the box in the corner, going across, and identify this using the pattern as A root 2. All right, go through, take a look at the 3 equations that you have created. Find the single equation where you can actually get an answer for A. It's not a combination of 2 different or 3 different unknown values. In this case, it's actually the first one, and now we know what A is actually equal to. So we're going to go over to the other locations, and everywhere we see an A, we're going to go ahead and plug in what we just found. So this is 13, and then drop the equal sign, drop the variable. Notice that the Y is isolated. That's our answer for Y. We're going to go through and do the exact same thing with the next one. Plug in what we know, and then just slide everything up. So in this case, it looks like X is isolated. We also have our answer for X. Let's move on to the next one. Do the same thing. We want to identify from the smallest angle. So across from the 45 is going to be A. Since these are congruent to each other, that means that opposite them, those sides are also going to be congruent. And then starting at the box in the corner, go across and identify that with the pattern of A root 2. Take a look at the 3 equations that you just created. Find the single equations. You can actually get an answer for A. In this case, it's going to be the hypotenuse here. So I'm going to go ahead and take that off to the side just where I have a little bit more space. 14 is equal to A root 2. And then we're going to solve. We know that's multiplication, so we're going to have to divide by root 2 both sides. Root 2's cancel. We're going to end up with 14 over root 2 is equal to A. However, we cannot have that root in the bottom of the fraction. We're going to have to rationalize. So what we're going to do is we're going to multiply top and bottom by root 2, which is fine. So root 2 over root 2 is just 1. Multiply straight across. That's going to give us 14 times root 2. And then in the bottom, we're going to get root 2 times root 2, which is root 4. But the square root of 4 is 2. Drop the A straight down, and then we can simplify the 14 and the 2, and that's going to give us a 7. Don't forget to carry that root 2 with you. Okay, now that we know what A is equal to, we go back to the triangle, and everywhere we see an A, we're going to plug in what we just found. So 7 root 2, and then just drop everything else down. Drop the equal sign down, drop the Y. Looks like the Y is isolated. That's our answer for Y. We'll go through and do the same process in the other location. Plug in what we know for A, 7 root 2, and then just drop down the rest of it. Drop down the equal sign, drop down the X. Looks like the X is isolated, and it looks like we have our answers for this triangle.